video, we will discuss the calibration into further extent by giving a practical example of how a calibration in industry is performed. Okay. Instrument calibration, one of the primary processes used to maintain the instrument accuracy. Calibration is the process of configuring an instrument to provide a result for a sample within an acceptable range. Eliminating or minimizing the factors that causes inaccurate measurement is a fundamental aspect of instrumentation that also falls within the scope of calibration. Why devices need calibration? Every device used for process critical measurement should be checked periodically and routinely to verify if it continues to deliver the same required accuracy. Where adjustments is possible, a device measuring outside of expected limits should be brought back to the acceptable tolerance level or performance level. But if there are non-adjustable equipment, the deviation of measurement should be recorded and the decision should be made by the person who's using the instrument to measure the quantity. In the case of temperature measurement equipment, the properties of bimetal and thermocouple wires change with use of time, resulting in measurement drift. So we all know what is the drift. So drift is the output of an instrument, change in the output of an instrument when the input remains constant, the output reduces due to various different environmental factors. So when the input is constant, output changes, reduces or drifts due to various environmental factors. That is called measurement drift. Here the measurement drift is caused due to deterioration of thermocouple wire. Additionally, the thermocouple probe may be damaged in service, possibly mechanically, such as corrosion, rapid deterioration of the wire, etc. RTDs and thermistors are also both fragile devices, easily damaged, so hence they should be checked periodically. Calibration of temperature sensors. Temperature sensors, exclusive optical pyrometer, are calibrated by the following methods. By reference to the equilibrium temperature of standard primary calibration, by comparison with standard of thermometer or pyrometer certified against standard secondary calibration, by comparing with the secondary standard thermometer which has been calibrated against the standard instrument at the primary or secondary levels. Bureau of Standards calibrates and certifies 3 standard instruments. So one of the Bureau of Standards in Chennai is in Taramani, NML, National Metallurgical Laboratory, checks and calibrates the manufactured thermocouple and RTDs against 3 of these: mercury in glass thermometer, platinum resistance thermometer, platinum rhodium thermocouple. The certified mercury thermometer are of sufficient accuracy for most engineering works are normally employed for checking and calibrating other thermometers, which are to be used for temperature measurement in industries and laboratories works. Okay. Now let us understand how a thermocouple is calibrated. So before understanding thermocouple, we are yet to enter the unit 2 where thermocouple principle, operation and working got discussed. We are yet to go to that unit, but briefly let me tell you, thermocouple is a sensor. That thermocouple is an instrument used for measuring temperature in industries. So it has basically 2 junctions. One is cold junction, another one is hot junction. So cold junction, just with the name you can say the cold junction is kept at 0 degrees, inserted into the ice bath that contains crushed ice, while the hot junction is kept at the point of temperature measurement where we need to get the temperature measurement, from where we need the temperature measurement from. It can be the furnaces at 1200 degrees, it can be hot stoves at 100 degrees, it can be 500 degrees, the kitchen out stoves available in hotels. So the hot junction and cold junction, when they are held at 2 different temperature, they produce a thermo EMF, and this EMF is produced, and the EMF produced is directly proportional to the measuring temperature. Okay, now let's see how it is calibrated. Okay, for checking the ice point, the bulb and the stem of the thermocouple are surrounded with a mixture of crushed ice, water open to the atmosphere, while the other point, the hot junction, is kept near the point of measurement. Okay, and the stem point is checking for suspending of the thermometer in the steam apparatus. So they use a steam apparatus where the standardized mercury thermometer approved by the NML National Meteorological Laboratory is kept in the steam bulb where the odd junction of the thermocouple is held. This odd junction of the thermocouple measures the temperature of the water in the bath, while the thermometer is kept above the water bath with steam surrounding the bulb but not immersed into the water bath. Okay, something like this. If you see, water is here, thermometer is kept here, and the steam is surrounding the water, and here they have missed completely the thermocouple setup. So thermocouple odd setup will be near the thermometer, and the cold junction will be kept in the ice, in the crushed ice box. Okay, so